Now see, first question from exercise 1.2. Question is, find the derivative of function y equals to f of x using the derivative of inverse function x is equals to f inverse of y in the following. For example, y equals to root x is given. That means we don't find derivative directly here. That means we know that when we differentiate y with respect to x, we get a dy by dx, and derivative of root x is 1 upon 2 root x. But here we have to convert given function in inverse form first. So see the solution of first subquestion. So in solution of first subquestion, we write the given function y equals to root x. We denote this as equation number 1. Now this equation we write y is equal to f of x is equal to root x. Now in this question we have to find derivative of this function, but instead of finding derivative of y with respect to x directly, we have to find derivative of x with respect to y. That means we have to use this concept, dy by dx is equal to 1 upon dx upon dy. That means we have to differentiate x with respect to y here. So we convert this equation 1 x in terms of y. So we write squaring on both sides, of equation 1. So when we square, we write here y square equals to square and square root get cancelled. So y square equals to x, that means x is equals to y square. So we have to find dx upon dy. That means we have to differentiate with respect to y. So derivative of x. So we write here derivative of x with respect to y as dx upon dy, and derivative of y square with respect to y, that is similar with derivative of x square with respect to x, that is twice x. So here derivative of y square with respect to y, we write twice y. Therefore dy by dx is equal to 1 upon. So we replace the value of dx upon dy by 2y. So we write here 1 upon 2y. Now we require this y in terms of x. So from this y square equals to x, we can replace this y by root x from equation 1. So we write here 1 upon 2 root x from equation 1. So if you check, derivative of y with respect to x is dy by dx, derivative of root x with respect to x is 1 upon 2 root x. So here we get dy by dx is equal to 1 upon 2 root x. Here instead of finding derivative directly, we have to find the derivative by making the inverse of given function. So we write solution in this way. Now see second subquestion, y is equal to in root 2 minus root x. So first we have to write the inverse of this function, that means value of x in terms of y. So for that we make square on both sides. So we denote this as equation number 1, squaring on both sides. So making the square of both sides, we get in left hand side y square, in right hand side square and square root get cancelled. So we get 2 minus root x. We require the value of x here. So we transfer this 2 to left hand side. So we get here y square minus 2 is equal to root x. Now we require the value of x. So taking square on both sides, we write here taking square on both sides. So we write this as y square minus 2 is equal to x. That means we have the value of x as x is equal to y square minus 2 its square. Now we have to find dy by dx. For that we have to find dx upon dy. So we differentiate with respect to y. Therefore dx upon dy is equal to, now we have to apply the power rule first. So we write power in multiplication. So we get 2 into y square minus 2 raised to the power 1 into derivative of this bracket derivative of y square is 2y, derivative of 2 is 0. So we write this as 2 in bracket y square minus 2 into 2y, that is 2 into 2, 4y in bracket y square minus 2. Now here we have to replace this y and y square in terms of x. So we write here this y square as, we have the value of y square minus 2 directly. So we denote this as equation number 2nd. So we first write the formula. Therefore dy by dx is equals to 1 upon dx upon dy, that is equals to 1 upon. So we replace dx upon dy as 4y in bracket y square minus 2, 1 upon 4 in bracket. We have the value of y, which is 2 minus root x, and we have the value of y square minus 2 from equation number 2nd, which is root x. So we write this as 1 upon 4 root x into root 2 minus root x. So in this way we find derivative of y with respect to x. Now see subquestion 3, y is equals to cube root of x minus 2. So we have to convert this y in terms of x, or we can say x in terms of y here, that is inverse of this function. So we take cube on both sides. So we write here taking cube. So we denote this as equation number 1, taking cube on both sides. So in left hand side we write y cube, here in right hand side cube and cube root get cancelled. So we write here x minus 2. Now we require the value of x in terms of y, so we transfer this minus 2 to left hand side. So we get y cube is equals to, y cube plus 2 is equals to x. Therefore x is equals to y cube plus 2. Now we have to differentiate this x with respect to y. So we write here, therefore differentiate with respect to y. Therefore in left hand side dx upon dy is equals to derivative of y cube with respect to y is 3y square, derivative of 2, which is single constant, so its derivative is 0. So we write here dx upon dy is equals to 3y square. Now we have the value of y cube, or we have the value of y. Here we require value of y square. So from equation 1, when we make square of both sides, so we write here from equation 1 y is equals to, so this we write in next step as x minus 2 raised to the power 1 by 3. This is value of y. We require the value of y square, so taking square on both sides, so we write y square x minus 2 raised to the power here 1 by 3 raised to the power 2, so which we write 2 by 3. So we write y square equals to x minus 2 raised to the power 2 by 3, or you can interchange the power, or you can write in this way also, cube root of x minus 2 is bracket square. So just we have to replace this y square in terms of x. You can write this power in the form of 2 by 3, or you can write cube root of x minus 2 is square. So this is value of y square. Therefore dy by dx is equals to 1 upon dx upon dy. So we replace the value of dx upon dy. So we have dx upon dy is equals to 3 into y square. So we calculate the y square as cube root of, or you can write x minus 2 raised to the power 2 by 3. So in this way you can calculate the derivative of dy by dx, or you can write 1 upon 3 cube root of x minus 2 bracket square. Now see subquestion 4, y is equals to log of 2x minus 1. So we denote this equation as 1. So we convert this x in terms of y. So for that we have to use logarithmic to exponential form and exponential to logarithmic form. So here we write base e. So we write here e raised to the power y is equal to 2x minus 1. That means we convert logarithmic form to exponential form. So from this we write value of x in terms of y. So transfer this minus 1 to left hand side, we get e raised to the power y plus 1 equals to 2x. Therefore x is equal to e raised to the power y plus 1 upon 2, that we write e raised to the power by 2 plus 1 by 2. Now we have to differentiate this x with respect to y. So we write here differentiate with respect to y. Therefore in left hand side we write derivative of x as dx upon dy. Now here 2 we can write 1 by 2 into e raised to the power y. So this you can write 1 by 2 into e raised to the power y plus 1 by 2. So 1 by 2 is constant with function e raised to the power y. So we keep 1 by 2 as it is. Derivative of e raised to the power x with respect to x is e raised to the power x. Here derivative of e raised to the power y with respect to y is e raised to the power y. And 1 by 2 is a single constant. So its derivative is 0. That means we find the derivative of first term, then derivative of second term. So we write here therefore dx upon dy is equal to 1 by 2 e raised to the power y. So we write here dy by dx is equal to 1 upon dx upon dy. 1 upon, now dx upon dy is 1 by 2 e raised to the power y. So this 1 by 2 we can write 2 upon. So we write here 2 upon e raised to the power y. Now we have the value of e raised to the power y, which is 2x minus 1. So we write here 2 upon 2x minus 1. You can denote this as equation number second. So you write here from equation second. Now see subquestion fifth, y equals to 2x plus 3. So first we convert given value x in terms of y. So we write here 2x is equals to, when we transfer this 3 to left hand side we get y minus 3. So we write RHS in terms of LHS and LHS in terms of RHS. So we write here 2x equals to y minus 3. Therefore x is equals to y minus 3 by 2. That we write here y by 2 minus 3 by 2, or we can write 1 by 2 into y minus 3 by 2. So we differentiate with respect to y, differentiate with respect to y. Therefore derivative of x with respect to y is dx upon dy. Here 1 by 2 is constant but with function y. So we write here 1 by 2 as it is. Derivative of y with respect to y is 1 and derivative of this single constant is 0. So we write this is equal to 1 by 2. Now dy by dx is equal to 1 upon dx upon dy. Dx upon dy not equal to 0. So we write here 1 upon dx upon dy, that is 1 by 2. So we write 1 by 2, that is equal to here 2. So in this way we find dy by dx, which is 2. You can check directly. Derivative of y with respect to x is dy by dx. Derivative of first term, so 2 is constant. Derivative of x is 1 with respect to x. So 2 into 1 we get 2. Derivative of 3 is 0. So we get derivative of y with respect to x as 2. Now see subquestion 6. In subquestion 4 we convert logarithmic to exponential form. Here in this example we have to convert exponential to logarithmic form. See, we denote this as equation number 1. So when we transfer minus 3 to left hand side, we write this as y plus 3 is equal to e raised to the power x. That means e raised to the power x is equal to y plus 3. Now we have to convert this exponential form to logarithmic form. So we write here log of y plus 3 to the base e is equal to x. So we get here x in terms of y as log of y plus 3 to the base a. Now differentiate with respect to y. Therefore derivative of x with respect to y is dy by dx. Derivative of log is 1 upon, so we write 1 upon y plus 3 into derivative of this y plus 3, derivative of y with respect to y is 1, derivative of 3 with respect to y is 0. So we simply write 1 upon y plus 3. Now we have to find dy by dx with the help of this dx upon dy. So we have to replace this value y plus 3 by e raised to the power x. So you can replace in this step also. So 1 upon e raised to the power x before substituting the value in the formula, dy by dx is equals to 1 upon dx upon dy. So we directly substitute this dx upon dy as 1 upon e raised to the power x, 1 upon e raised to the power x, that is equal to e raised to the power x. Now you can directly check the derivative of this y equals to e raised to the power x minus 3 by taking derivative with respect to x. Derivative of y with respect to x is dy by dx. Derivative of e raised to the power x, that is derivative of first term, is e raised to the power x. Derivative of this 3, that is derivative of second term, 3 is constant, so its derivative is 0. That means our calculated value is right. Now say subquestion number 7. So here y is equal to e raised to the power 2x minus 3. So we denote this as equation number 1. Now we have to again reduce this in the form of logarithm. So we write this in logarithmic form as, so we write here log of y is equal to 2x minus 3. So we write value of x or value of 2x is equal to log y plus 3. So we write here x is equal to 1 by 2 into log y plus 3 by 2. That means we divide both sides by 2. So we have to differentiate this function with respect to y. So we write here differentiate with respect to y. Therefore derivative of x with respect to y is dy by dx. Derivative of this 1 by 2 into log y, 1 by 2 is constant, so we keep 1 by 2 as it is. Derivative of log y with respect to y is 1 by y. Derivative of 3 by 2, which is single constant, so its derivative is 0. So we write here 1 by 2 into y, we have the value of y, that is e raised to the power 2x minus 3. So we replace the value of y as e raised to the power 2x minus 3. Now we have to find dy by dx. So we write here dy by dx is equal to 1 upon dx upon dy. 1 upon, so value of dx upon dy is 1 upon 2 times e raised to the power 2x minus 3. So this denominator term we write in numerator, so we get 2 times e raised to the power 2x minus 3. You can check derivative of y with respect to x directly from this. Derivative of y is dy by dx. Derivative of e raised to the power x is e raised to the power x. So derivative of e raised to the power 2x minus 3 is e raised to the power 2x minus 3. Then we have to find derivative of 2x. Derivative of 2x is 2 and derivative of 3 is 0. So 2 plus 0 we get 2. So in this way we find derivative of this y is equal to e raised to the power 2x minus 3. Now see last subquestion, question number 8. Y is equal to log of x by 2 the base 2. So this function in logarithmic form, so we have to convert it into exponential form for finding the value of x. So we write this as equation number 1. So we write in exponential form as 2 raised to the power y is equal to x by 2. So when we transfer this 2 to left hand side, we write 2 into 2 raised to the power y is equal to x. Now here power of 2 is 1, so we write here base is same, so we write power in addition form. So we write 2 raised to the power y plus 1 is equals to x, or simply you can skip x is equals to 2 into 2 raised to the power y till finding the derivative. Now we have to differentiate this, differentiate with respect to y. So derivative of x with respect to y is dx upon dy. Now 2 is constant, so keep 2 as it is. Derivative of 2 raised to the power y we find by the derivative of a raised to the power x with respect to x, that is a raised to the power x into log a. So derivative of 2 raised to the power y with respect to y is 2 raised to the power y into log 2. Here we use the concept d by dx of a raised to the power x is equal to a raised to the power x into log a. Now here in place of a we have the value 2, in place of variable x we differentiate with respect to y. So we write here derivative of 2 raised to the power y as 2 raised to the power y into log 2. Now we have to convert this 2 raised to the power y in terms of x. So you can replace this 2 into 2 raised to the power y by x. So we denote this as equation number 2nd, and we replace this 2 into 2 raised to the power y as x. So we write x into log 2. Now we have to find dy by dx. Therefore dy by dx is equal to 1 upon dx upon dy. So we write here dx upon dy as x into log 2. So we get here derivative of y with respect to x as 1 upon x log 2. Now for converting, you have to remember this formula. A raised to the power x is equal to y. This is exponential form. For writing this in logarithmic form, we have to take log of this y. So we write log of y, and we have to take base of log as a. So we write here log of y to the base a equals to x. That means power term we write in equals to form. So we write power at equals to, and this a we use for base, and we take the log of this y. So we have to convert exponential to logarithmic and logarithmic to exponential by using this formula.